Okay, waiting for your friends. We want to recall about last week's lecture on the noise. Nohaila is around? Your question last week was about, let me get the slide. You asked about if the signal to noise ratio for the input and the output are the same. It is the same if it is for ideal condition. I already upload the slide, yeah? I split into two for the Thursday and the Wednesday and the Friday class. Okay, so for the class, do you remember about the last week's lecture? Okay, so if you look at the slide, last week's, just to recall, last week's slide, I enlarge a bit. Okay, so if you do your signal to noise ratio for the input, for ideal case, your signal to noise ratio for the input will be the same as your signal to noise ratio as the output. Okay, because because there is no noise in the device itself. The noise comes from the input and it is being amplified together with the signal at the output. So the signal to noise ratio, I repeat, signal to noise ratio for input is the same as the signal to noise ratio at the output for ideal case when there is no internal noise generated in the amplifier itself. Okay, so if there is any question, for example, for you to calculate the signal to noise input for the output, for example, giving the signal to noise ratio input, so you can straight away know that the output signal to noise ratio output automatically, without any calculation from the value of your signal to noise ratio input. Get me? Because you need the signal to noise ratio input for the case of the internal noise, which is on the B. Okay, for the non-ideal. So for the non-ideal, you need to know the signal to noise input, signal to noise ratio input, then only you can get for the signal to noise ratio output. Okay, so that's to answer the Nohaila asked last week, if you remember. Class, I need your participation, don't just be quiet. So because Fauzi, is not only for gain 1, is for any gain. As long as for no internal noise at the amplifier. So the noise just comes from the input only. Just for ideal case only, when there is no here, for case B is non-ideal, you have internal noise. So for ideal case, there is no internal noise in the device. Okay, so add no additional. So whatever that you go in, either the signal or the noise, both are being amplified at the output. Okay, but for the non-ideal, the signal is being amplified, but the noise you have to add out with the internal noise in the device. Doesn't matter of your gain. Okay, Fauzi. So this what I told you is only for ideal case, which is no noise in the device. It's not that no noise input, yeah. As we already discussed, there is no such thing as no noise at all. So there is noise that comes in, but the device itself is no noise. So this is ideal case, which is seldom we get, but we can get this reference to calculate the non-ideal amplifier, which is with the internal noise. If we give you the internal noise and then we give you the, for example, the non-ideal signal to noise ratio, you can calculate for the non-ideal. Okay. All right. So we're not going to wait for the others. We're going to continue. So I need your participation, everybody, not only 1 or 2 person only. So we are going to cover on amplitude modulation today. So because your lab tomorrow will be on amplitude modulation, that's why I have your class today and your lab later. Okay. All right. So what is amplitude modulation? So these are just in words. So again, I do not want you to memorize. So if possible, try to understand and write your answer later in your own words. So information signal normally are being transported between a transmitter and a receiver. Okay, so normally as what we already did, there are 5 components in your communication theory. So you have your information signal, you have the transmitter, and then you have the medium, and then you receiver followed by the output data. So here is between the transmitter and the receiver being transmitted over a medium. It doesn't matter lah, wireless or wired. So the original form information is normally unsuitable. Okay, you see here unsuitable. So for example, like your voice, it is unsuitable to transmit to another place. That's why therefore you need to transform it to make it more suitable. So for example, your voice is at low frequency. So you need to modulate to a higher frequency in order for you to transmit. Okay. All right. So what is the benefit of modulation? So basically, it is modulation shift the spectrum. Is a better suit for the channel, and then you can do the multiplexing, and also you can control the noise. Okay. But for this subject, we're going to do more on the modulation technique first. Okay, so just recall back a basic sine wave, because we're going to use a lot of sine wave and equation, and this is the basic equation for a sinusoidal. So normally it can be E, so this is the unit V, so it can be E or V. Okay, so EM, this is would be the peak. Okay, and this is the angular, which is the frequency and phase. So sometimes we do it alpha or omega t plus psi. Okay, alpha would be omega t plus psi. So which contain of the angular, which is the frequency and phase. Okay, so I just recall this because you're going to use this later. Okay, so EM is the peak. So this is, it can be E, it can be V. So you need to check lah whether it's E or V. So you should understand, be able to understand, although it's E, that means it's still considered as the energy or the voltage. Okay, so this is the carrier signal, for example. So this will be the amplitude. Okay, so for amplitude modulation is very straightforward. So you're going to do the mathematics after this, but not for FM. FM and PM, it will be a bit complicated. Okay, it's not straightforward. So we're going to use the amplitude of the carrier signal. So here, information signal is analog. So this is analog. The information signal is the data that you want to transmit, yeah? And the V amplitude of the carrier. So this is the carrier signal. Okay, and you put the information signal into the amplitude of the carrier. You get it? Amplitude modulation is when you put the information signal in the amplitude of the carrier signal. Okay, so in other words, this is so I don't want you to memorize. If I see that you get this answer, that means you look at from the notes, because your final will be in the face to face. If the information signal is analog and the amplitude of the carrier is varied proportional to the information signal. Okay. So, okay, this is another thing that I want to, this is some basic things between the time and the frequency domain. Let me see whether your friends are here. Only 23 of you, many still missing. Okay, so this is the one that you normally use before this is during your past 2 years in the lab. You normally do time based. Okay, so this is a one frequency, this is another frequency. So when you convert to frequency base, it is only like a one peak only. Okay, so actually this should be the other way around, because if this is amplitude, I mean this is higher frequency, this one should be at the bottom. Okay, correct lah. Sorry. Okay, class. Okay, this is the frequency. That means it will give you, for example, if this is 10 kilohertz and this is 1 kilohertz, so it will give you just the one peak only if it is a frequency base, and this one will be known as 10 kilohertz, and the frequency is right for you. Any question? I cannot find my name. So okay, so this, for example, if this is 10 kilohertz, then this will be in hertz. Okay, and it will be, so for example, here is around 10 kilo. And this is 1 kilo. Okay. So this is a lower frequency. You can see that there is a lower frequency here, and this is will be higher frequency. Okay, so this is a combination of two frequency, for example, and you will see two peak or three and so on. Okay, so this is different. You can see this in oscilloscope, but you have to use the FFT in order for you to change from the time base to the frequency base. If you use spectrum analyzer, then you would have this x-axis as the frequency. Okay. All right. So when you do the amplitude modulation, you see, okay, this is higher frequency, and the higher frequency would be your carrier. And modulating signal is the one that means your information signal. Okay. And then after it is being modulated, it will become something like this. This is AM wave. Okay, so transferring from low frequency information, so your information signal is low frequency here to a higher frequency carrier. Any question? Okay, so one thing that you have to understand is your carrier is something like the aeroplane. Aeroplane is a carrier, and you are the passenger, so you sit in the carrier. So the same thing as our modulation. Your frequency, higher frequency is the carrier, and the information signal is being input or modulate, change proportional with the carrier signal. Okay, so the same as your the equation that I gave you earlier. When it is amplitude modulation, that means the amplitude of the carrier is being changed. Okay, so for amplitude modulation, you just straightforward, you just put in the value of your information signal into the amplitude. Okay, so the frequency would be the frequency modulation, then you change the frequency. The phase modulation, you change the phase. Okay, so this is ideally when you have a nice low frequency sinusoidal and a high frequency sinusoidal, you get a nice amplitude modulation wave. But in real, you'll be not exactly that. Yeah, so it's something like this. This is your audio signal, for example, and the carrier signal. So your signal after modulation is become like this. All right, so we're going to do some mathematics for the amplitude modulation. So first is the carrier. This carrier we denote as the C. So this is the amplitude signed with the omega C, the frequency of the carrier. So omega C, frequency of the carrier, VC, amplitude of the carrier. Take note, you can write down. Okay, to amplitude modulate so now is amplitude modulation. To amplitude modulate the carrier, its amplitude is changed according to the level of the audio signal. So this is your audio signal, VM. Normally, M means the modulating signal, with the sign omega modulating signal as well, omega M. So this is the amplitude of the modulating signal and the frequency of the modulating signal. Amplitude of the carrier varies sinusoidal means about a mean of VC. So VC is the amplitude. So remember, we change the amplitude of the carrier. When the carrier is modulated, its amplitude is varied with the value of the modulating signal. Okay, so this is the carrier, the amplitude. Can you write down the equation that we have earlier? Okay, write down this VC, sine omega CT first. Okay, after that, you add up VC, your amplitude of the carrier, with the modulating signal. So your signal becomes VC plus Vm sine omega mt. Got it? This is your carrier. Okay. So the amplitude of the carrier is Vc. You add up with the modulating signal, the whole thing, not the amplitude only, because you want to transmit the whole modulating signal. So the amplitude of the carrier Vc becomes Vc plus Vm sine omega mt. And then, okay, this is the amplitude we already add up with the modulating signal. And then you multiply with the original sine omega ct. This is the carrier frequency. Okay, so you open up this, becomes Vc sine omega ct. Can you do that? And let me know what you get. You open up the equation and write down what you get from the equation. Okay, you open up this, you get right in the party chat. What you get from the first equation. Open up, you get Vc sine omega ct plus no, you don't get squared. You just multiply sine omega mt multiply with sine omega ct. Okay, thank you. Who is that? Okay, thank you, Amir Faris. Okay, so now you see the equation is sine omega ct sine omega mt. I asked you to find the theorem right earlier. So sine times with the sine, what do you get?
Cos doctor.
Huh? Sine times sine, you get?
Sin square.
Sorry?
Sin square.
Mana ada square? Ada square ke? Can you write the chat? Solve the omega VC, the first term is okay. Solve the second term. This one you get again, you get back the, so this is VAM.
Macam identity lah kan doktor?
Yeah. So
Okay.
sine times sine, what do you get?
Okay, sekejap doktor.
Because you have sine omega m t multiply with sine omega ct. So sine times sine, what do you get?
Lagi tulis ke doktor ke cakap je? Tulis kan doktor. Betul ke doktor? Doktor mute.
Taklah naknya, itu C tolak C tu apa tu? Sine times sine.
Sometimes sin. Tadi doktor cakap sin omega C.
Tu mana omega awak? Omega C tolak omega,
Okay.
omega bukannya C.
Okay doktor.
Some others can answer at the chat. Can answer at the chat. I want another answer. Naim tak betul lagi tu Naim. Any other answer? On the sine multiply with sine. Put in full because I left you with on the slide there. Vm sine omega mt times with sine omega ct. So I want the answer in terms of Vm, omega m, omega c.